Hi, and welcome back to the channel. Today, I'm excited to show you how you can set up GRDB. But first, what is it? GRDB is a tool that runs on top of SQLite. It lets you interact with the SQLite database in a more SwiftUI way. So instead of dealing with SQL statements to create a table, we have more Swiftier syntax. It also has support for concurrency and combine, and there's a bunch more tools too, but we are just going to cover the basics. I found GRDB to be really good for having either a local database or if I wanted a more advanced caching layer for, let's say, Firestore, where I pull the Firestore data and I cached it in GRDB. It's also a good alternative to core data, and they have some similarities since core data also is a layer on top of SQLite. But enough talking, let me show you a walkthrough of the application. So here you see the finished application where I can add restaurants. You see I can add a restaurant here. I can add 2 dishes that will be associated with that restaurant. So if I tap this tell burger, you see I have spicy burger and cheeseburger. And the same goes for the pizza too. So here I have the application at the moment without the database. So the code is pretty simple. It's just a navigation view with a list. And each restaurant that is supposed to show her, if I tap them like I showed you, we'll go to the restaurant details view and we will do some concurrency here and fetch the dishes associated with that restaurant. Nothing special. Okay, now let's set up the database with GRDB. So I already have it downloaded with Swift packages. So let's create a separate folder for a database and call it local database and move and create a new file called local database. Cool. And move into it and import the GRDB, of course. I'm going to create it and you can have it as a struct actually, which is pretty cool. Move to local database here. And first we need a type that can write. So let's declare this property called writer, and it needs to, of course, conform to a database writer. You can see a type that writes into a SQLite database. Cool. And we also want to perform the migration when we have access to the writer, because there's a method to migrate, and to do that method, we need the writer. So let's create an initialization. Go with underscore and writer and database writer. It throws because we have to do a try. First we go with self.writer. Cool. And move to try.migrator. We don't have it yet. We will have this property soon, or this object soon, and migrate with the writer. Okay. We also need a property that can read the value of our database. So go with var reader of type database reader. And actually, since this database writer, actually the protocol itself conforms to the database reader, so we can take advantage of that and use you can use that one in this computed property. Okay, to make Xcode stop complaining, let's create migrator. So create a new file and we are going to extend the local database. So go with the default convention when you're extending. So a plus, and what we want to extend it with, a migrator. Cool. Move into the file and import GRDB again. And now we want to extend the local database. And we are creating the property that we need, which is this migrator. And it's going to be this database migrator object. We are going to set it as a computer property because we have to do some configuration here and call some methods. So first, let's instantiate it. Is equal to database migrator. Then this is optional, but I think it's useful to know. So I'm going to show you. It won't take long. So I have this if debug and if, and I'm going to say migrator dot erase database on schema change. And yeah, it does exactly what it says there. So if there's some changes to the schema, you end up actually erasing all the user's data. And this is pretty useful for debugging, but you don't want to delete all of user data. So it is useful to have, but have this debugging around it just for safety. Okay, let us move to the migration itself. So use migrator.register the migration. And if you're used to SQL, this will make a lot of sense. But in just a quick summary, essentially this is, you can view it as version control. So you can think of this like when with GitHub, for example. So let's say we created our first table and we called it the restaurant table. But then we want to have another table like the dishes and have those dishes associated with the restaurant table. So the next version then, of course, would be to have version 2. Or you can treat it as commits. So you can have in the first one restaurant, for example, and in the second one, when you want to add another table, you can write dishes here instead. So you can view it as simple version control. Okay, but we are going to create both dishes and restaurant in the same migration, so it's going to be no worries for us, but let's create it. So let's go here and we need to say try. And we need this method, create restaurant and dishes tables and dish tables. We're going to pass in the database because we need it. And since it's only going to be used here, we can have this function private. So let's take this here out and move it here. And we of course have to have underscore, and it's going to be of type GRDB.database. Yeah, that should be right. And of course it throws, we use the try. And now let's create the first table. So go with db.create, you see here table, and go with restaurant, not restaurants. That's really important. I'm going to get back to that. And you want table here. I don't know why it did that body. I don't want that. I want to have it like this. Okay. And then we're going to set the first column, which is going to be the primary key of this table. I'm not going to let GRDB take care of this. So we're going to do this one manually because we want to set this key as the foreign key for the dish. And so let's move along and create the column for the name. And it's of course going to be a text and it's going to be not nil. Okay. Then let's move to the dish table. Just copy this one to make our life a little bit easier. Go with dish here. And this one is going to be really interesting. I'm going to show you. First, we want to let GRDB take care of the ID itself. So use this method here. Then we're going to have the same name and it's also not going to be nil. Then we're going to have this method, which is super interesting. And this one belongs to our restaurant. It's really important to get this one right. And we can have the on delete and you set it as cascade and we can have it as not nil. So let me explain this one. First, we have this on delete, and this one makes sure that when the restaurant is deleted, all its associated dishes get deleted too, which is really useful. And here, actually, essentially what this does is that now we actually have a foreign key called restaurant ID, and it will be associated with a particular restaurant. We of course have to do a little bit more later in the model object, but this is super interesting. We don't need to create another column called restaurant ID. So let me show you how the schema looks now. So I'm going to change the window here and we can move here. And you see here, we have the restaurant table with the ID and the name, and there's an associated value here. So this is going to be the foreign key, I think, yeah, foreign key and we call it restaurant ID, and it's going to point to the ID of a particular restaurant. We have the name and the ID. You get the idea. Okay. Let's move back. And this one works. I'm going to return the migrator. I forgot that. It's all right. And what is really essential here is that this restaurant follow the convention that is outlined in the documentation. And you can just view it as a simple model object without the capital letter first. So don't go with restaurants. You wouldn't go with restaurants if you have model object. No, you go with restaurant. And don't go with dishes too. And don't go with underscore either. Because if you do that, you have to do more manual configuration yourself. And you miss out some of the cool features like this. So this won't work. Okay. Command B, and it should compile now. Everything should be fine. Okay. But now we actually don't have created any connection to the database. So let's do that. Let's create a new file, call it local database. We're going to extend it again. And the naming convention I've seen is persistent. Yeah, just keep it like that, but not with a backscore at the end. That makes no sense. Okay. So do the same thing again. Import GRD, not group activities, but GRDB, and extend the local database. Cool. And now I'm going to create a singleton and use the singleton pattern here, but the same will apply. What we have done here, the same will work if you're injecting with the environment key and so on. It's the setup that is important and what I want to demonstrate, not dependency injection itself. So I'm just going to keep it really simple and create a static. Let's shared equal to make shared, which is going to be this one here, static func make shared. And what is that one going to return? It's going to return a local database. So let's create the connection here. Do a do and a catch and have it print out a fatal error if something goes wrong. So error dash there and error. Okay, cool. Now, since SQLite this is serverless, we don't deal with servers here. The database itself is going to be stored on the device itself. Then we are dealing with files and folders instead. So let's create the folder first. We need help from the file manager. So let's create an instance of it. Cool. Now we need to create a path for the folder. So the folder is going to be equal to try file manager and URL for in appropriate for. Yes, that one is the correct one. Let's make this a little bit nicer. And for set it to application support directory. This is the usual directory you use when you create a database. And the next one is going to be user domain mask. So it's going to be in the user's home directory. We don't need to specify a common directory. So set this one to nil, and we want this to be created if it doesn't exist. So set this to true. And at the end, we want a database folder. So go with database here. And is it a directory? Remove this one, set to is directory. And go with true, of course. Really nice. And now we have to, of course, create a directory because now we just have the path itself. So go with try.filemanager.create directory, and we need at this one, yes, at folder dot path, I think. Yeah, path. You can go with path. No, we can just go with folder. We actually have, yeah, it's a URL. We can go with folder. Cool. And this one is a little bit confusing when you look at the documentation, but essentially when we create the database the first time, this wouldn't fail. But if you have this one as false and you already have a database and it tries to open a database, this one will actually fail. So we need this. It's very important to have this one as true. Okay, let's move to the database URL because we just have the folder, but we need, of course, the database file itself. So go with folder, appending path component, and go with db.SQLite. I don't think we need, now we don't need that, so remove that one. Okay, so let us actually create the database itself. So now we have the path here, but we need to declare the writer. And this will make a lot of sense now. So go with here with database pool, and then you will have the path, which is going to be what we have created here. It's going to be this folder and it's going to be this file. So go with database URL.path actually. Cool. We haven't returned it yet, but you actually have two. This is important because you actually have two options here. You can either use a database queue, which will have a serialized connection to the database, or you can have a database pool. In general, I think the database pool is faster and it's the one I've seen most people use. But I also seen that if you don't know which one to use, you should use the database queue. But in our case, we're going to use the database pool. Nice. Now we can actually instantiate the database, because if you remember, what we need when we instantiate the database is a database writer, and the database pool conforms to the database writer, which makes sense because this is the first connection that we have to the database itself. So we need to get that writer from somewhere. So go here, and like we need a writer. So go with writer, and now we can actually return the database. And now if you look at the whole image, this makes sense. We use the file manager, we use the appropriate directory for creating our database folder. We create the database file. We use the database pool to create a connection or open a connection if it's already there. So the next time we instantiate the database, it will already be there. And then we actually create the database. Now we instantiate the database with a writer, and we're going to use this writer throughout our application. So if you go back to the local database, it creates the writer, and we're now here. And we use that writer to create our first migration, and that migration is going to create our table. And now we have actually set up the whole database. So in the next video, we're actually going to use the database to create the restaurant and the dishes. We're going to use combine to listen to the new restaurants, and we are going to use concurrency to create both the dishes and the restaurants themselves. So if you found this useful, leave a thumbs up. Other than that, thank you for watching, and I'll see you next time.